All right, so we are going to be moving on to graphing inequalities. We've graphed inequalities when there was one variable, but now we're going to look at two. So we're going to do this little intro activity first. You're looking for a particular shop. If all you know is that the shop is south, so below California Street, shade the possible area that the shop could be. So we're going to find California Street, which is right there. And we're going to shade everything below it because we are looking that it is south of California Street. Okay? If you need more time, just pause the video, but I'm going to go ahead and move on. After given more information, you now know that the shop is south of California and west of Masonic. So I'm going to find those two. So here's California and Masonic, which that would be easy if I could actually see it. Oh, there's Masonic. So it says it is south of it, so it might be below it, but west of Masonic Avenue. So only to this side of Masonic Avenue. So the only place that matches both of those requirements is this left bottom square here. This is south of California, but west of Masonic. So whatever place we're looking for is going to be in this area. Can you see how when we only had one criteria, we just shaded everything below it? But when we had two criteria, we had two things to talk about, two things to put into consideration. And that's what we're going to be looking at with graphing inequalities. So to look at it, let's take out the situation part of it and look at it just with a problem. You're looking for a particular point. If all you know is that point is below the line 1/2 x plus 4, shade the possible area that the point could be. First of all, we need to figure out what that one is. So 1, 2, 3, 4. This is going to be that line. And we know that it's below that. So we know that point has to be below this line. So I'm going to shade everything that is below that line. So we're not caring about what's up here because it's not below this line. So let's look at another one. After given more information, you now know that the point is below that, so still all of this, but it's also to the left of x equals 3. So here's our x equals 3. So when I look at it, it needs to be to the left of this, so over here, but below this. This area no longer matters because it's not to the left of that line. So I'm looking to the left, but below. So this is going to be that criteria. So the point I'm looking at is somewhere in here. So now let's put that into a little bit more perspective for us. So this is the 9.1 note. You do have 9.1 homework also tonight. And we'll talk about at the end about you submitting it to me. So let's look. Inequalities with one variable can be plotted on a number line as in the case x is greater than or equal to 2. So we're going to go to 2. We're going to put a closed dot because it has equal to. And x is greater than, so we would have just drawn a line like this. Hopefully you remember that. The solution to an inequality is a point which, when substituted in for the variable or variables, makes the inequality a true statement. The points C, D, and E, C, D, and E, are all solutions to the above inequality because they all fall in line with all of these possibilities that it could be. So let's look at it with two variables. Inequalities with two variables need to be plotted on a coordinate plane, as in the case of y is greater than or equal to x. So what they did is they graphed the line y equals x. So that means that when y is 0, x is 0. When x x is 1, y is 1, and so forth. So that's also called our parent function, if we remember that. Our linear parent function, because it's the most basic. And then we know that we want it to be greater than, so they shaded above it, which we're going to be talking more about that. So the points C or A, C and A, are solutions to the above inequality. Because for each point, the y is greater than or equal to the y value. The shaded region is also known as the solution region because all the points which lie in that region represents the solution. So what we did is we graphed y equals x. We wanted where y is going to be greater than x. So if you look here, my y value is greater than or equal to my x. My y here, 0, is greater than or equal to -8. Versus, actually, point B should have also been in it because it's just off. Because it should have been plotted right there. Sorry about the thing. Because it falls right on the line, and it can be equal. But if I look here, here's my x and here's my y. My y is not greater than my x, so D could not meet that criteria of y needs to be greater than or equal to x. Okay? Of course, if you have questions about that, send it my way. So let's look at the back. So we're going to learn to graph them, and then we're going to graph the line. And what I want you to do is either highlight, or if you want to circle, I'm going to highlight. We use a solid line for y is greater than or equal to, or less than or equal to. And we use a dotted line for greater than or less than. Okay? So, and then we're going to show below the line, shade below the line if it's less than or less than equal to, and above the line if it's greater than or greater than and equal to. Sorry. Okay, so we already have it in the form y. So our beginning spot is -3. So I'm going to go to -3. Well, let's put our b in. Let's put our m. Remember, I'm going to stick my m over 1 so that I have a rise and a run for it. So I'm going to go -3, 2, 3, put a dot. And then to rise -2, I'm going to go down 2 over 1. And I'm going to plot that graph. That line. Continue going the opposite direction. We should be good on this. We've been graphing lines for years now. I'm going to use my ruler and graph it. There's my line. Okay? It's a solid line because it was greater than, it had the equal sign with it. So it stayed solid. So dotted or solid, it's solid. And is it going to be above or below? So we have this symbol, y is less than or equal to, so we're going to go below. I always think of it as less than, so that's going to be below. And so I'm going to shade below. Every single point that's in this shaded area, if I plug it in to that equation, into the inequality, it's going to be a true statement. So if I wanted to test to make sure, I could pick a point and plug it in. All right, let's look at the next one. Number 2. My m is 1/2. My b is -3. This time it does not have an equal, so it's going to be a dotted line. And it is y is greater than, so it's going to be above. So start at -3. I'm going to rise 1, run 2. Continue with that pattern. Do the reverse of it. Again, we should be pretty decent at these. If you need to pause the video because you need more time, please do that. I'm trying to make this video not any longer than it needs to be. Except for it's supposed to be dotted, and I just messed up on that. So, I'm going to come in and erase every now and then to make a dotted line. There's my dotted line. Now, make it very clear. I don't want to have to guess if you have a dotted or a solid line, so be sure that it's very clear which one it is, okay? All right, and then we have that we're going to shade above. So we're going to shade above. And yes, this does kind of wear our pencils out. All right. If you need more time on that one, go ahead and pause the video. If not, I'm going to move on. All right. When we have x by itself, we keep forgetting this for some reason. There's an imaginary 1 there. So my slope is 1 over 1. My y-intercept is -4. It does not have an equal with it, so it's going to be a dotted line. But it is y is greater than, so we're going to go above. So I'm going to start at -4, 2, 3, 4, and rise 1, run 1, and I'm going to keep going with that pattern. Connect my dots. Y'all know me, I like to fill the graph with as many dots as I can, but not all of you do that. That's okay. It's going to be a dotted line, so I'm going to go through and erase some of those to make it dotted. And you don't have to erase. You can choose to do the dotted without. That's okay. Just go ahead and do dotted originally. I'll see if I can remember that next time I have a dotted one. And I'm shading above it because every one of these points is a possible answer choice. And since this is an easy one to look at, let's pick 0, 0. So if I pick in 0 is greater than or equal to 0 minus -4, 0 is greater than -4. So that's just showing that you can pick a point to test out if you shaded the right direction. All right, last one. All right, my slope is -2/3. The y-intercept is 5. Has an equal sign with it, so it is a solid line. I like those better. I always forget to do the dotted part. Is it going to be above or below? Y is less than, so it is going to be below. This one was a below. All right, so let's look at that. So I'm going to start at 5. 1, 2, 3, 4, 5. Always start at my y-intercept. Down 2 over 3. Down 2 over 3. Down 2 over 3. The reverse of that is up 2 to the left 3. Once you've gotten enough points, you can draw your line. Okay. This time it was supposed to be a solid line, so I have a solid line. And I'm going to go below. So below that line is this direction. Now this is why I hope that my remote students came and picked up their packets, because you do have homework tonight over 9.1. And I need to see dotted line, straight line, and shading, and I can only see that it's really hard to do on the on a computer. So if you can do it on the computer, that's fine. If not, then do it by hand and send me pictures. I don't mind. Some of your parents already have my my phone number if they want to text it, or if you want to just send it through email. If you have any questions, please send them my direction. I know this is a whole new concept, and I kind of went pretty fast through it. So if you have questions, please send them my way, or I can do a Zoom call with you later. All right, y'all have a good day.